Okay. We're coming together with the Rube Goldberg here. I have to raise, these are the cuts I made for the gear tooth. I have to raise this up off of, it's usually right, this piece here is usually right flush on top of this. But that'll block the gears, so what I did is I made some 1/2-inch spacers here that we're going to drop on top of here. And there is a little bit of a lip here, so they can't slide out, which is fine. It's basically, this is just to make sure that this is got the proper symmetry to it, the depth and everything. So now I have enough room underneath here. Yeah, let's get as close as we can. Let's see where we're at then. I have to punch these holes, and then I can drill them out and tap them. Then I can mount these bolts on there, and those are the mounting bolts. And see if I can keep from shutting this off this time. Now that I got those spacers up underneath there. Let's see what we got going. Alright. Now, work on centering that a little better. Pretty close, but we get it. Make sure we're as close as we can get it. Get Actually, it's pretty darn close. All the way around. Just shy. Huh. I like it. I'm going to punch this puppy while I got it here. Right one. That looks like it right there. All right. Magic hammer. This is a steering knuckle off of an old 1950s Chris Craft. This used to have a threaded cone out here, and it was a ear out here with a hole in it. It makes a good hammer. I think I made this about 30 years ago. Now I'm going to take it all back apart again. More later. One more of the 4 here. Okay, that should do it for the mounting bolts. It's going to be a 1/2 inch. Let's see what you can see here. Right here. Right, this piece, this is a front wheel drive bushing out of an Explorer. Now, this bearing's a little noisy. On the road it'll sing, so that was the reason it was replaced. But for the purposes of this project, it's ideal. I've cut the teeth in the flange here and reduce the diameter slightly. Now I'm going to take a 1/2 inch plate, cut a circle out so this will fit in. These are threaded, so then I'll bolt this to a 1/2 inch plate, and that'll be the basis for the rotation of the welding table. The plate will be under here, and the whole system will rotate like this. I'm going to use a nut, an Acme nut. I'll weld it on to a couple of studs and use that for to put a quadrant on here, and then I'll use that Acme nut. I'll turn a piece of rod stock to the proper threads, and then I'll use the Acme nut to rotate the table. So this is just, you know, as I'm progressing, I'm just trying to keep it up to date here. Check out the weird pattern. I didn't set any of the locks on the tables, and the funny thing of it is, none of the numbers changed on the readouts, but look at that pattern it dug in there. I was just digging, I had a 1/2-inch bit trying to get all the way through a 1/2 inch of steel. And something got out of whack. But I'm just taking maybe 200,000, 250 cuts now, so we'll see what happens.
Yeah, what actually happened, you can see on the left-hand side where there's like an ear out there. What happened, the table wasn't locked, and the head of the mill was in rotation and cutting. And what happened when it got to that side, it actually started moving the table. And as it got out there, it went into further rotation. You see where it made a loop down. As it went into rotation, all of a sudden it started cutting and moving the table back the other direction. Well, I had my back turned, I was doing something else, and when I got back over there, it had found its way back into the almost to the normal spot where it was centered cut. And I just reset everything and locked the table and let it continue going round and round the cuts. And I actually ended up using that piece, putting that on the bottom side. You can see it here, it's on the bottom. All right, I have to do the voiceover on this because I have the music playing in the background and I can't knock it out of there. I'm just getting ready to fit up the plate that I just turned on the 2D. The reason those extra holes are in there has to do with the diameter. Too many. I didn't know. I thought it was inches and it was metric, and then it wasn't metric. And anyway, I had 3 sets of holes, but finally got it right. Fortunately, I had plenty of stock to work with. But the second hole now is to fit up the drive motor, which is a windshield wiper motor out of a 92 Lincoln Town Car. I'm just setting it up there so I can measure the original. I made a gear for it but I didn't take into consideration. I thought I was going to mount the motor on the other side. After putting it together and building the rest of it, I found out I had to put the motor on the bottom side of that plate. So I created a situation where, you see here now, I've got quite a bit of space between the shaft of the motor and the driven gear there. So what I'm going to have to do is, I think it's 1/850, 1 inch 850 thousandths. I'll cut a 2-inch length of 1-inch stock and cut a 20-tooth gear in a 1-inch stock, and then turn down the inside of it so that it'll fit over that shaft.
Okay.
I'll show you the videos of that as we go along.
Down here and get it close.
But
So
remember to shut your radios off
I'm
when
using
you're making these videos. YouTube goes crazy if you don't. But I'm explaining there is I have to put 2 uprights on the side, and then that plate will be the rotation point.
The uprights will
And
attach here and here.
I'm talking about
And
putting
the
a
rotation will be going this way. So there's room for all
Acme
this to
nut
clear.
in
The only thing is now I have
gimbal
to,
in there, and then
cut
that'll
this 1-inch gear
in a threaded rod, Acme
out of
threaded rod,
make it a
make
long
that thing
shaft gear.
rotate.
It'll last. It'll be. Well, that's what this measurement is.
This is again where I ended up having to shut down the audio portion of it because I got too much music playing in the background. But all right, let's get this one a cut and see if it's actually recording. what I'm doing here is I marked off a length on each end. The centerpiece that it's right there is that's where the teeth are going to be. One end I'm cutting down for a shaft to the teeth, and the other one I'm the other end of that where the teeth are. That part that's marked off is I'm just machining that, so I've got a piece to hold on to while I'm for the work stock. When I put it in the indexing head. So that's what's going on right now. Is I'm cutting the shaft on one end and a holding shaft that I'll cut off after I get the gear teeth made.
Okay. Just a piece of, started out as a piece of 1-inch stock and turned it down on both ends so I'd have a piece to hold. I'm going to end up putting a hole in all the way through for a bolt, but in the meantime I need to turn this, turn the inside of this to accept the shaft from the windshield wiper motor. So let's take this out of here and see how we did. Looked pretty good. We're getting less and less spill all the time. I increased the speed a little bit on this cut, and it seems to have cut much better. Let's see what we got here. There's my, this was a 1-inch piece of stock. This is a 1-inch gear with 20 teeth. Came out pretty good. In fact, it came out so good, I don't see where it started and stopped. I think I'm finally getting the hang of this. Okay, got more setup to do now. See that? Can you? Let's see if I can do that. I started the hole from the other side before I turn this thing around. So what I've got now is a 5/16. I've got a 5/16 hole in there now. I'm going to set it up in the rotary head Cornian checker and machine the other end to accept the shaft from the windshield wiper motor. Okay, what happened? I ran out of film or memory stick when I was cutting this. I had it set down inside there with these V-blocks. Made a mistake. The hole that I had drilled, the through hole, 5/16, that fit the 5/16 roughing end mill, and but there's no place for the chips or anything to go out the bottom because when it's sitting on solid metal there. But anyway, I dropped the end mill in 600 and rotated it. Make this out or not here. Okay. Dropped it in 600. Brought the rotary head out 10 thousandths. Brought it down on the cut to the eventual circumference. It's 82 thousandths, including to get it out there, and then the bit itself, half of the bit makes up the difference. But anyway, you put that into 180-degree rotation, and it takes it around to this side, and you can see the flat on the inside there as it goes back across to this side, another 180, and then it resumes the flat on this side. So what you've got is an oblong rectangle in there, a rounded rectangle. Then I brought it out 300 and put it into 360 degrees rotation to finish the 470, I think it's 475 cut. Now that goes on, take it over here. Okay, that rotation, that cut in this, you can see there's the oblong piece that this fits into. So what I do is I put that in there. Back this out a little bit. Okay. Put that in there. Now that's, I have to tap that into place a little here. And I've got a, funny, this is a windshield wiper motor out of a 1990 or a 93 Lincoln Town Car. But these three holes that go around here, and the hole that holds the wiper configuration on there, are all metric. This is a 6-1 metric. I've found a 40 millimeter 6-1 metric, and this, I'll put some Loctite on here when I mount it permanently. But for now, that's for setup purposes, that's fine. Now we're going to put it, show you how it goes into here. This is the okay. Now you can see how that mounts in there. So now that windshield wiper motor there will rotate that gear we just finished, and this particular thing right here is a flange on a. This is a hub off of a Ford front four-wheel drive front. This is the front hub on a Ford Explorer, and all that'll happen is this will rotate this hub, which in turn will rotate this is upside down. I have to manufacture the brackets and so forth for the holding fixture, but this is all about the rotation now of this chuck. This is a 4-jaw chuck that's going to rotate and hold the work for a welding table. So we're progressing quite well here. This is a 6-to-1 ratio, which the speed should be just about right, but I'll have variable speed and reversible on this thing anyway. So anyway, that's a good start.